In this video, we will be completing task 1 of the exercise, and you'll see that I've set things up with the instructions on the left of my screen and the inputs tab on the right of my screen. You can set things up how you like. If you only have one screen, then you'll need to switch between the instructions and the inputs tab. If you have multiple devices, then I would recommend putting the instructions on your second device, whether that's a tablet or a laptop or whatever your secondary device is, and have the input screen as your main on your main device. So I'm not going to read out all of the instructions, but you can see on the left of my screen here that we have task 1, input parameters, and the purpose of task 1 is to enter the inputs for our Markov model on the inputs sheet. And we've split task 1 into a number of steps. And the very first step we're going to attempt here is step 1.1, enter transition probabilities for treatment A. So if we go to the right tab now, where we have the inputs on the right of the screen, you'll see that there's this long range here in row 24, where we need to enter the transition probabilities for treatment A. So there are 3 states in which patients can move from that state on the next cycle. So that's the asymptomatic state, the mild state, and the severe state. Once patients are in the dead state, they will stay in that state. It's an absorbing state, so we don't need to enter any transition probabilities for that. But the very first transition probability we need to enter is for those patients who begin the cycle in the asymptomatic state. What is the probability that they will remain in the asymptomatic state on the next cycle of the model? And we need to enter that probability into D24. So if we go back to the instructions, you can see that we've been given the results of a very simple trial where there were 100 patients in the asymptomatic state. They were provided with treatment A and observed for a month. And during this time, 91 patients remained in the asymptomatic state. So the first transition probability we have here is 91 out of 100. So we can write equals 91 divided by 100. Press enter. And so that's a transition probability of 0.910. Now, you could have also just typed in 0.91. That would also give the correct answer. You can see that's been colored green because that's correct. For the next one, we have, if we look on the instructions, 5 patients that started as asymptomatic, but they worsened slightly during the month and moved to the mild state. So we've got 5 out of 100. So I'm going to do the other approach here. I'm going to put 0.05. And again, that's a completely valid way of doing this. I'll press enter. And it says marking in progress. And that's correct. Cell E24 has the correct value. Let's move on to severe now. So look on the left of the screen. There are 3 patients who worsened more seriously and moved to severe. So that's going to be 0.03. And then finally, from asymptomatic to dead, there was 1 patient who died and moved to the dead state. So that's going to be 0.01. Okay, I'm going to move things over slightly so I can now see the transitions out of the mild state. So let's deal with mild to asymptomatic first. Now, there's a different set of patients here in the trial, 80 patients who began in the mild state, provided with treatment A, observed for a month. And of these, 6 moved to the asymptomatic state. So they improved. 6 out of 80. So we're now going to just use a fraction here. So equals 6 out of 80. Press enter. And that's correct. So the next one is mild to mild. How many patients stayed as mild? And you can see that's 68 out of 80. So I'm going to write equals 68 divided by 80. Press enter. The next one is severe. There are 4 patients who worsened, moved to severe. So that equals 4 out of 80. And then finally for this state, mild to dead, that's 2 patients who died. So 2 out of 80. Okay, and then the last state we need to deal with for now is severe. So we can see there are 50 patients who were in the severe state, provided with treatment A, observed for 1 month, and none of these patients improved to either the asymptomatic state or the mild state. And we can see here the assumption underpinning this model is that patients in the severe state cannot improve. So this is a disease for which once a patient reaches a severe state, there is no going back to being asymptomatic or mild. And there are some diseases in the real world that are like this, there are some that are not. So have a think about what diseases in the real world would have this property, that once you get to a sufficiently severe state, you cannot return to asymptomatic or mild. So for severe to asymptomatic, the transition probability is 0. I'm just going to enter a 0 there. And then for severe to mild, it's also 0. I will enter 0 for that. For severe to severe, we have 48 patients out of the 50 who remain as severe. So I'm going to enter 48 out of 50. And then finally, for severe to dead, we have 2 patients who died and moved to the dead state. Okay, so that is the end of step 1.1. You can see that O24 is correct. And in a couple of moments, it will confirm that step 1.1 is complete. Step 1.2 has been unlocked. And you'll see a couple of things. On the left, we now have step 1.2. Step 1.1 has disappeared now. The instruction sheet only includes step 1.2. If you do wish to look back on the instructions from an earlier step, please take a look at the Google Doc, and you can look at instructions from previous steps or future steps if you wish. On the right of the screen, on the Inputs tab, you'll see that we now have a few more columns that are now visible. So in step 1.2, our task is to enter relative risks for treatment B. The other thing it points out here is that the mark sheet is now visible. So if we look down here, you can see this sheet was not available before, but it is now. And the mark sheet keeps track of where you're up to. So task 1, step 2, and it tells you which of the steps have been completed. So we completed the test question at the beginning, and we've completed step 1.1. Right now, step 1.2 is incomplete, and all future steps are locked. And if you wish, you can browse down here and take a look at what steps are coming up in the remainder of the exercise. Let's go back to the input sheet. What do we need to enter as the relative risk for treatment B for patients in the asymptomatic state? So we can see over here that the relative risk of moving into a worse state with treatment B is approximately 0.619. So that's what we're going to enter into this cell here. So 0.619, press enter. Now it does say later on that in note 2 that once you've completed this step, the values that we're entering now, these approximate values, will be replaced with much more precise values. And the reason for that is that later in the exercise, we're going to make this model probabilistic. And these particular parameters will be assigned a log normal distribution such that the means, and these are the mean values we're entering now, they're going to be, they're not going to be round numbers. Okay, we're going to need to have 15 decimal places for these to be considered precise in the spreadsheet software. And it's tedious to enter 15 decimal places right now. So that's why I've asked you just to put in an approximate number now, and it will be fixed later. Okay, so for the relative risk for treatment B from the mild state, that's slightly different. That's 0.701. So let's enter that now. Okay, so that's the correct value. And in a couple of moments, that will turn green and the spreadsheet will expand. So these are now correct. And if you click on them, you can see there's now a more precise value up here that's been put in. Same for this. Okay, and the reason for that is later in the exercise, as I said, we're going to make these probabilistic. And what I would like is for your results in the first part of the exercise, when the model is deterministic, I'd like them to be exactly the same as they will be in the second part of the exercise, when the model is made probabilistic and your deterministic values will come from the mean of those distributions. I'd like there to be consistency, so that's why we've put those really precise values in right now. Okay, so let's move on to step 1.3. You can see on the right screen on this inputs tab, we now have transition probabilities for treatment B. And again, there are 12 of these cells we need to fill in, very much like we had for treatment A. But for treatment B, we may have to apply these relative risks. So it's a little bit more complicated. If we look on the left of the screen on the instructions, you can see that step 1.3 has become available. And the task here is to calculate the transition probabilities for treatment B. Now, just remember that the relative risks apply for transitions to worse states. So the assumption is that treatment B will slow the progression of the disease. It will reduce the probability of a patient moving to a worse state. But it will not improve the probability of moving to a better state. So if you're in the mild state, treatment B will reduce the probability that you worsen and move to severe or dead, but it will not increase the probability that you will improve to the asymptomatic state relative to treatment A. So we just need to be a little bit careful of that. So where do we begin? And you might think that we should just begin with this one again, the asymptomatic to asymptomatic, but I'm not going to begin with that. I'm going to do that after I've done the other three. So let's do asymptomatic to mild first. Now, the probability of this, we're going to use a formula here. We're going to say it equals, and I'm going to come across here to asymptomatic to mild with treatment A. It's that cell there. Then I'm going to multiply that by the relative risk for treatment B when you're in the asymptomatic state. So my formula says E24 multiplied by S24. And I'm going to press enter. So you can see that's 0.031. We can compare that to 0.05 under treatment A. So there is a lower probability of moving from the asymptomatic state to the mild state each month when we have treatment B. Okay, we do a similar thing for asymptomatic to severe. So equals, and then we go across to asymptomatic to severe, that one, and then we multiply it by the relative risk asymptomatic, again, that one. Okay, and now we have asymptomatic to dead. So that equals asymptomatic to dead with treatment A multiplied by the relative risk. So G24 times S24. Now at this point you might think, well, what do we do with asymptomatic? We're not multiplying that by the relative risk. But also we need to be careful because it's not the same as it was for treatment A. The reason being that all of these must sum up to 1. And these are lower probabilities than they were for treatment A. Okay, so what we need to do for asymptomatic to asymptomatic is we need to say this equals 1 minus the other probabilities. And there's a few different ways that we can do this. But one way is to do 1 minus the sum of these three values. I'm just going to close the bracket. There we go. Okay, and that's correct. I've noticed this cell here has been quite slow to mark, but it's finally caught up and marked it now. So that can happen sometimes, that there's a short delay in Google marking it. Remember, in order for the marking system to work, edits made to the Google Sheet are saved and synchronized with Google Server, and then Google does the marking, and then it's synchronized back to your computer. So every now and again, there can be a delay in this happening. Okay, let's move on to the mild state. And this time, the 1 minus the other 3 probabilities is going to be the mild to mild probability. So we're going to do that one last. Let's start with mild to asymptomatic. That one's easy because we don't apply the relative risk. So that just equals mild to asymptomatic with treatment A. There it is. Okay, now what about mild to severe? We first of all need to take the probability with treatment A. So mild to severe is that one. And then we need to multiply it by the relative risk for the mild state, so the different relative risk. Press enter. And then mild to dead, we're going to take the probability for treatment A, mild to dead, and again multiply that by the relative risk for the mild state. And then finally we can do this mild to mild, which is going to be 1 minus the others. So I did a sum function last time. I'm going to do a slightly different approach this time, just to illustrate that there's various ways you can do this. So we'll do 1 minus this one here, minus this one, minus this one. Press enter. So mathematically it's equivalent to doing the sum function. Various different ways you can do exactly the same thing. And the exact formula doesn't matter as long as you get the correct value. And then finally, we're on to the severe state. Now, if you recall, asymptomatic, mild, you cannot move to those states from the severe state. So in this particular model, we can just put zeros in each of these. Now, from severe to severe, that's going to be exactly the same as it is with treatment A. So you might think, well, can we just enter the equals 48 out of 50? And no, it's not good practice to do that. And the reason being that later in the model, we will be changing the probabilities, the transition probabilities for treatment A, and the relative risks. They will all be changed during the probabilistic analysis. And so it's really important for consistency that we put a formula in here rather than hard coding any values. So we're going to say equals, and it just equals the severe to severe probability in N24. And we'll just wait for that to be marked. And then the last one here is severe to dead. And again, that's just the same as it is for treatment A. We've got severe to dead, it's this one here. Press enter. Okay, so step 1.3 is complete and step 1.4 has now unlocked. So on the left, we can see we now have the instructions for step 1.4. You can see below these, it says that 1.1, 1.2, 1.3 are now complete. And on step 1.4, we need to enter list prices for each treatment. And again, I'm not going to read all of this out. I'll let you guys read that in your own time. But the important part is that treatment A has a list price of $2,000 per month and treatment B has a price of $3,000 per month. So you can see a few more columns have appeared. And in column AM, we're going to enter $2,000 for treatment A. We'll just wait for that to be marked. And then in AN24, we enter the list price for treatment B, which is slightly higher, $3,000. Okay, so step 1.4 has been completed. In step 1.5, we need to enter an initial price reduction for treatment B of 0. So later in the exercise, we're going to apply a price reduction to treatment B to find out by how much would the list price of treatment B need to be reduced through negotiations in order for B to be cost effective compared to A at various different cost effectiveness thresholds and under various different assumptions. And in practice, there's many different complex ways in which the effective price of a treatment can be reduced, all sorts of risk sharing agreements, rebates, various different mechanisms. For this model, we're going to keep things simple, and there is a simple percentage price reduction that will be applied to treatment B. And so we're going to begin with a reduction of 0. We're just going to use the list price, and then later in the exercise, as I said, we're going to try and apply a price reduction and see what happens. So for now, just put in 0 and press enter. And that is the correct answer for now, just a default price reduction of 0. In the next step, 1.6, we need to put in a formula into AP24 that will take the list price for B, the $3,000, and apply the price reduction that we just entered in AO24. Now, in the default analysis, there's no price reduction. So you might think, well, can't we just enter $3,000 here? And that would give us the correct value, but this would not work later in the exercise when we perhaps we change the list price or we change the percentage price reduction. By putting a hard-coded value in AP24, changes to the list price, changes to the price reduction will not have any impact on the final price. So we need to use a formula. And what you'll see here is that some rows have appeared showing various different price reductions from 10% up to 90%. And there are some gray cells here. Now, you can only enter a value into the pink cell. You cannot enter values into the gray cells. And when you enter your formula into that pink cell, it is going to copy it down automatically to the gray cells and test whether the answer is correct. And if the answer is correct, then the step will be marked as complete. And if it's not correct, then you'll have to try a different formula. And so the reason this is being done is to make sure that your formula works when you change the price reduction. So it's not good enough for it to give us the correct value now. It needs to work for other price reductions. So just to illustrate this, if I was to put in equals AN, press enter, well, that is the correct value in the reference case, right, where there's no price reduction. However, the automatic marking system has copied that down and it says that this cell needs attention. The value is correct, but its formula does not copy correctly to the other cells. So we need to do something better than that. So how would we do this? We need this to equal the list price minus any kind of price reduction when applied to the list price. So one way of doing this would be to say that it's, I'm going to put an equal sign there, equals, and then I'm also going to, oh, sorry, I'm editing the wrong cell. I'm going to go back to the final price, that equals AN24, and then I'm going to multiply it by, and I'll open a bracket, I'm going to multiply it by 1 minus whatever that price reduction is in AO24, and then close the bracket and press enter. So now when the price reduction is 0, it will be 3,000. And you can see here when the price reduction is 10%, it's 2,700. When the price reduction is 90%, it goes all the way down to $300. So that's exactly what it should look like. And you can see that step 1.7 is now opened. We need to put in other healthcare costs. So these are healthcare costs that are incurred not dependent on the treatment that you have, A or B, but they depend on what state you're in, asymptomatic or mild or severe. And the assumption is that the more severe your health, if you're in a worse state of health, then you will incur additional other healthcare costs, trips to the doctor, trips to hospital. They're going to be more frequent if you've got if you're severely ill. So the assumption in this model, we're keeping things very, very simple here. In practice, you would need to be looking at the resource use and assigning unit costs to that resource use. It's much more complicated in a real world model than it is here, but we're just illustrating principles here. So $800 per month if you're in the asymptomatic state, $1,000 per month if you're in the mild state, $2,700 per month if you're in the severe state. They're the very simple assumptions here. So AT24, that should be 800. And then AU24, that's going to be 1,000. And then if you're in the severe state, it's going to be 2,700. So that's correct. And in a couple of moments, it will mark this step as complete, and step 1.8 has now been unlocked. And now that we've done the transition probabilities and we've done the costs, the final part of this task is to enter the health utilities. So we have 3 to enter. We have asymptomatic, we have mild, we have severe. And the reason that we're not entering a health utility for the dead state is because once you're dead, there is no more health utility, right? You have no more quality of life. There are 0 quality adjusted life years, QALYs, when you're dead. And I should have mentioned this a few moments ago, but for the healthcare costs, the same applies. Once you are dead, there are no ongoing healthcare costs. So that's why we didn't enter a healthcare cost for the dead state. So what do we enter as the health utility for the asymptomatic state? So you can see here, health utility for asymptomatic is 0.85, for mild it's 0.75, and severe it's 0.4. So let's start with asymptomatic, that's 0.85. And then for the mild state it's 0.75. And then finally, for the severe health state, that's just 0.4. Okay, so that's the correct value. And in a couple of moments, it will say step 1.8 complete. Step 2.1 has been unlocked. And in task 2, we're going to be calculating the costs and qualies for treatment A. And that will be in the next video. Thanks for listening.